Imagine on slide 1, the title slide, we're talking about reactive networking. And what I mean by this is that SDN is so 2011. And NFV is so 2014. And frankly, you know, we're not only beyond the post-marketing hype cycle of these technologies, they're being deployed. But what becomes interesting about these different pieces is that the reactive part, as we've discussed for so many years as an industry, is that SDN and services orchestration has been solely focused on configuration and provisioning of physical and virtual appliances. We just heard a couple talks on this. It's worked out extremely well for the industry. Getting APIs into our devices has moved the ball forward. Great, check, done. I think we actually might even be able to stop talking about this because we can just about assume that it's now ubiquitously deployed across the internet. The other half of the equation is, as also has been discussed already, is the analytics and telemetry that's coming out of the network. What's interesting about the telemetry piece is that, thank God, as an industry, we have moved beyond the notion of just polling these devices and are actually pushing information out. You know, we have reached the mid-'80s of computer science on this piece. And there's no doubt, there's been much discussion over how to be able to create a platform for network data analytics, you know, utilizing open source projects like Logstash, using NetFlow, IPFix, and now even pushing routing information, both BGP, IGP, and all the MPLS information directly out of the network. The key is connecting those two together and creating not only, I want to configure and provision a service, but I also want to get all of the information out of the network such that if there's a topology change or a change in state of the data center or the cloud or however these physical or virtual appliances are working, that then can cause a reaction to reprogram the network. But we're not done. The common mistake is that these two platforms, an SDN controller or service orchestration platform, or a data collection or data analytics platform, are the end goal. And they're really not the end goal, because what we've missed as an industry is that we love talking about Luke, use the API, used REST interfaces. This isn't where the action is. We have to realize as an industry that when competing in a cloud marketplace or data center delivered services, the PaaS layer becomes key. Because as an industry, we have not been able to move into the PaaS layer such that somebody actually could orchestrate and easily build an application or workflow beyond a NAT load balancer or virtualized router up at the PaaS layer. And the PaaS layer that I'm talking about, for example, is a Cloud Foundry or any of the other private public clouds that are available. So to this point, that reactivity and the creation of networking or services domained applications at the PaaS layer becomes key. Some of these types of services was described by Sunil. He described it as virtual CPE. I'll describe it as a virtual branch. When discussing how to configure and provision the virtual branches, we need to realize that there are different roles in the industry, and it's usually very, very glossed over that an IT professional needs a different view of the data than the end user that may be working through a portal, or those that are actually needing to be able to operationalize the service. The next view, of course, is a product manager. The ability to see when designing a service out of the cloud that's constructed, just again simplistically, a virtual router, a load balancer, a firewall, or if it's a media service that there needs to be an ingest of uncompressed data, transcoded, metadata applied and then played out. These are now services that can be built out of that PaaS layer, and there are different roles in the industry that need different views. This probably sounds completely obvious. Of course there are. But as an industry, we're learning this in a very, very hard way because we did realize back in 2010 or 2014, it's just not that hard to fire up a hypervisor or a container, pick your favorite technology. They both are applicable in certain areas, but the key piece of this is that the ability to trace through the physical resources that are available, the physical topology, the virtual overlay, the services overlay, which is actually what's seen as the service. a policy layer, which is what constructs the actual workflow topology in the data center. As a networking guy, I do think of workloads and workflows as being in a topology construct in the data center. But again, the ultimate end user is working all the way up at the PaaS layer and trying to just simplistically and easily design a service that can be deployed on the net. Okay, so slide 1, there was the title slide. Slide 2, there was 4 elements to the talk. It's starting at the PaaS layer through the SDN orchestration in the network, and they are linked together, and this is creating reactive networking. We discussed the virtual branch automation. One view of what you can see with respect to your virtual branches. And then moving up to that service orchestration, we discussed the different layers. So far, we're not doing too bad. And so when we hit these different layers, we can pop this up to a different view of what we're interested in, and it's the age-old question, do you need to build a 5 nines network and a 5 nines data center to build a 5 nines service? Or does a 5 nines network actually enable application developers to only be able to deliver a 3 nines service? And what we're ultimately only interested in is the highest possible availability and service assurance for the service itself. And this is a really interesting balance in why lifecycle management becomes so critical. And when we take a look at it, it's all of these elements on the right-hand side that need to be put into the equation. We can take different views of the service design and the health. And if you're a service designer or product manager, there are different elements that need to be delivered and orchestrated together. And these come not only from a physical or virtual CPE, Yakov remain calm, or the actual service design of the virtual appliances themselves, which is what's represented on the top of this slide. And remember, one of the biggest challenges we even have as an industry is a service change order. A customer ordered one customer prem device and a bunch of virtual appliances out of the cloud, and then all of a sudden they want to order it at the same time to 2. Our OSS systems are so complex that becomes a massive overhaul in those systems. And when it's a model-driven network and when it's a model-driven orchestration platform, we can easily do those types of change orders and understand the delivery of service before it's been delivered to the service. Again, this isn't beyond our comprehension that when we design a service, we want to enable triggered OIM. Is the service actually working before we deliver it? But we've spent so much time as an industry talking about magical SDN, magical clouds, we forgot that many of these pieces and the different roles in the industry that must be paid attention to, unfortunately, had been forgotten. So as we move around that wheel, again, SDN configuring and provisioning the network actually forwarding packets, straight up bit banging that we all love, pushing out analytics up to the PaaS layer. The point about where we are in the state of the industry now is that the network can be simplified and can massively scale. So let's just address this quickly. Again, segment routing, we've talked about as an industry and at this conference for the last couple of years. This is actually us as an industry removing protocols from the network and removing state from the network itself and be able to create services along a dynamic label switch path by programming the label stack at the head end. It's now through standards bodies and implementation such that it's proving out that it can even outperform from an availability through point, as well as a bandwidth point of view, being able to more efficiently utilize the network itself. And that's what this graph is showing. And in fact, I believe I showed something similar to this a couple years ago. So this, again, for me, becomes to the point where I can now integrate the 2 domains of data center and WAN, as were recently discussed, and orchestrate them cross-domain or multi-domain at the same time by having the network interact with each other and having that PaaS layer. If, as an industry, we can get to the point in the PaaS layer where today they can, an application developer can launch a workflow or workload requesting CPU, RAM, and storage, if we can get to the point where a simple variable associated with a network is actually a part of the way that we're developing and designing these services, like how much bandwidth am I going to source or sync, we then are able to have a role in this part of the industry. And today, rounded to the nearest integer in most PaaS layers in public clouds or in open source PaaS layer platforms, simple things like requesting or launching a workflow and requesting bandwidth, and then potentially a string of features associated with it can't even be done, as well as our role and responsibility, again, from the analytics side. How did that workload perform? How did that workload perform? Which applications or elements of that workflow actually communicated to each other or passed through? These are ways we can directly bring networking value to a service designer that they can't do today. In addition, not only is it associated with segment routing and label switch PaaS or IPv6 segment routing, we've also now worked towards SDN controlled replication trees and removing replication state from the network itself. And this was a fantastic move forward. So now let's talk about scale. And we're now going to go down into straight up virtual forwarding plane, and where we recently worked with the industry to open source something called vector packet path through the fast data community. And it is straight up bit banging forwarding plane interacting with the x86 platform that was recently discussed via DPDK. So we published some numbers, and I highly recommend you tomorrow afternoon, you go hear my colleague Maciek, who's going to really spin up the propeller hat and go into the deep, gory details of performance. But really what I want to show here, and it may be a bit challenging to see, is that 2 ports, 10 gig E, hey, we're passing 20 gigs at this point, and we've got a lot of possible throughput. And in fact, when looking at scale, we know as an industry we can scale high throughput with high table size. And this sounds obvious to many of us in the room, but there are a number of other projects out there that are only available to the industry in which those two pieces don't go together, high scale and potentially high throughput. As you're reading these slides, as I'm talking, there's a couple things I want to point out. In 24 cores on a 4-socket computer with another 48 cores available, 200 million packets per second and 480 gigabits per second. That's a shalada bytes. That was a joke. There's actually no such thing after yada bytes to shalada bytes, but nonetheless, I digress. Anyways, here's my point. Just in my career, when I was one of the architects of the CRS-1, which was one of the first 40 gig per slot routers, you can quickly do the math. In 2004, it was a 7-foot chassis, 16 slots of 40 gig on the order of 14 kilowatts. This is a 2RU computer utilizing 24 cores, and it's 12 slots of that router. We haven't done too bad as an industry in about 10 years, or little over 10 years. So when I go through a couple of other numbers, it doesn't matter if it's layer 3 or layer 2. 480 gigs, again, out of 24 cores, with another 48 cores available on a 4-socket computer available to run other services or other compute workloads, or applications or control planes as you like. Really quite efficient with doing ACLs as well. Again, a slight drop to 462 gigs. All of these numbers are with 0 frame loss. Now, that sounds great, but is that all that these cores can do? And I just want to show you output of a couple of pieces that, again, Maciek will go into detail. I'm sure you've memorized this slide in the font already. But here's my point. When using a vector of packets and to be able to warm up the instruction cache and be able to highly optimize that forwarding, there are still cycles left over. We have not exhausted the actual software forwarding plane. We've exhausted the hardware itself of the way x86 computers are being built, either the NIC or the PCIe. And so we have more headroom, and what does that headroom turn into to us as an industry? More features. We have more cycles available than a current x86 platform has in I/O bandwidth to be able to write more features. So that is a key piece. The next one is that virtualized forwarding has really been dinged for massive amounts of delay that have gone through these particular forwarding planes. Over 120 microseconds in some cases, or 120 milliseconds, in many cases as measured. With respect to VPP, running a test since last week, sending 7.7 trillion packets. The largest amount of delay was 3.5 milliseconds, including all of the outliers. And so delay, jitter, variance in the forwarding plane, I think is something that, as an industry, we don't need to be worried about. And the point of us open sourcing this was simply to move the industry forward. And move the industry forward where you can take advantage of all of our practical L2 features, IPv4, IPv6, all the usual NCAPs, MPLS, segment routing, just move the industry forward and make this ubiquitous that we have a piece of networking that can also send that telemetry data with no impact on packet performance. And so this is that project, and I highly recommend that folks take a look at it. So let's move around that wheel over to analytics. As we've just begun to move the industry to be sending data out of the network versus polling tens of thousands of devices in the network, we know that we have a number of common metrics or pieces that we need to be able to understand, and they're all a function of the different data that's currently coming out of the devices, either through completely unstructured data like syslog or through NetFlow, IPFix, or through the routing piece. Each one of these now, whether we want to tag them all with SDN protocols or not, is kind of beyond the point because the protocols are available for us to be able to do work. And so a platform for network data analytics, and something that we're working on in the industry as well, utilizing open source projects to be able to, again, move the industry forward towards a reactive networking, is a midstream project to be able to integrate many of these pieces together. And what you're trying to roll out, again, is a platform and a portal and a application development environment in which machine learning algorithms and other event correlation and processing algorithms can be built and can be used to be able to have the network be reactive. And so towards that end, predictive services management is one of the applications and some of the algorithms. It requires deep networking domain knowledge because you actually need to know the elements in the network, the construct of the network, the function of the different devices that are out there at the different layers in the network to be able to understand what went wrong. I can tell you what's interesting, and most operators understand this, when you turn on any type of alarm correlation eventing system in the network, pushing data out of it, everything glows bright red. Everything is completely broken. Well, that's not obviously the case in reality. So it becomes really a very challenging analytics and machine learning problem to find what is actually wrong and then be able to reduce truck rolls, pinpoint the problem in the field, and fix just what is actually wrong. And we can demonstrate this in a number of different ways, correlating all of the data coming out of the network. And this turns itself into an operator portal that can easily summarize all that information for network operations or call center to be able to understand the relationship between the compute, physical, networking resources across the different layers that we've discussed to what customers are impacted and what's the state of the service. Being able to, what we've learned over the years employing programmatic networking, reactive networking, et cetera, is that as things move around in the data center, whether it's a distributed delivered service or a centralized delivered service, is the relationship between those layers and identifying them and holding accounting for how virtual machines are tied to physical resources and tied to orchestration and customer delivered services is a huge challenge. But what's interesting is when you have an understanding of what could potentially be wrong in the network, and in this case, packets are being lost. Well, we all know where exactly in the service flow are these packets being lost. When you're able to identify and relate the delivery of the service to the physical compute resources that are actually being employed for that service, you can then tie it together and pinpoint, in this case, a computer actually was impacting that service delivery, and it wasn't a fiber cut, a topology change. But realize, as VMs or containers are mobile inside a data center, this is an incredibly challenging problem to build into a service orchestration platform. And from there, what other customers were actually impacted by that computer can be derived. So building that into those multiple layers of the platform becomes key. Now, also tying together the analytics that I was discussing before are routing analytics, and the BGP monitoring protocol is something that I've personally been working on for a very long time and is now available from multiple suppliers in the industry. And it's not just sending, here's my BGP data, here's my link state data, here's my MPLS traffic engineering and VPN topologies pushed out of the network in real time. And I talked about this a bit last year. All of this software has been open sourced. The goal is move the industry forward in understanding routing telemetry, impact of the network, and one ultimate goal, which is fairly straightforward, is be able to correlate video quality analytics for a broadcast television system to network analytics. Did a region or did a country tile all of their televisions because a link flapped? Those are the types of questions. What is the state of the service and how is it related to how we're building networks and deploying networks? Routing analytics is the routing, and load analytics becomes that piece. And from there, we've open sourced a UI, and it's now being picked up by academia that's doing routing analytics and route views and KIDA and a number of other folks, because it's the first time where we can see routing information pre-policy. We've built a lot of routing analytics information based upon send me a BGP peer feed and it'll all be good. Well, think about it again. That is post-policy, and that's one view. And what BGP monitoring protocol does is send you all updates from all peers without any policy applied. And then you can derive a lot of statistics out of that as well. So as we put these pieces together, this is another representation of the picture, and I'll show you the original one in a second. The big blocks, the business outcomes and the service design for business outcomes is where we need to focus in 2016 and 2017, and not necessarily at individual platform layers, and understanding this big wheel of reactive networking and reactive service delivery, where on one side we're config and provisioning, and on the other side we're receiving telemetry data being pushed out of the network, and there is a full reactivity between them. So as we take a look at that first picture again, the way we've thought for years about SDN, NFV, or analytics is that apps run on our platforms. They're networking related platforms. They're config and provisioning. We'll write a lot of tools and apps, and everybody will love our SDN controllers. And we miss the point. We haven't delivered a service yet, because the business solution is in the service construct and the service design that's coming out of delivering mobile services, delivering media, video, consumer, business services, et cetera, at the top, which we should target up at the PaaS layer because we have ignored it as an industry. Wait for it. So when we focus just on the business services layer, this is about as good as Mike gets in PowerPoint, by the way. So, is that when looking at the business services, we're looking at being able to create those service catalogs. We haven't defined a way in the industry yet actually how to define in metadata the requirements and what's necessary from our VNFs or potentially coming out of the network. So a service catalog can be built to be able to build workflows, a service order application for the end customer or for product manager, and then a service assurance application, what actually happened when you ran that service. It requires all of these to work together. And what ends up coming out of that is a representation here, a customer marketplace, a service assurance portal as we saw, and the ability for an IT professional to debug and diagnose all of those layers from the actual compute and networking resources through physical interconnectivity, virtual overlays, the actual service model that's being deployed, the policy model that's used to create that workflow, and then that application PaaS layer of who actually talked to who and what did somebody experience when obtaining that service from a provider, and what did the end, say, enterprise or residential or mobile customer get delivered to them. So towards that end, thank you very much, and thanks for your patience earlier as I was talking through the slides and went through this quickly, but I appreciate the time today. Thank you very much.
Thank you, Dave. Thank you for sharing the insight, particularly about the OpenVPP and machine learning for analytics. That's the way to go, and that's what we're looking through Azure Cloud as well.
Excellent, Luan.
Okay.
Karidi, you want to try this?
Discuss it.